Hey there, everyone out there. Big thanks to Max for sending in this question. This is related to the Chapter 2 test for our Summer Math 1, but really it can help with anybody with ordered pairs trying to find a function. So we have a set of ordered pairs here. We have the x and the y coordinates, so we start at the origin, and then we go to 0.12, 0.28, 318, and 432, and that's all that's been given to us. So what I've set up here is a little extra column for the delta, the change that we see happening in the y's. Because the change that we see happening in the x values here is consistently increasing by 1, we know that the y should be consistently increasing by something if it's linear. So we see an addition of 2, an addition of 6, an addition of 10, an addition of 12. So that tells us that this linear form, y equals mx plus b, is not going to work for us. It cannot be linear since this change is not consistent. So we're going to go ahead and get rid of that option. So then another option we might think about is this an exponential? And an exponential function actually uses the input as the exponent. So if this were exponential, we'd see some sort of dramatic changes happening, like very large changes, probably larger than this. And actually what we can do here also is look at the second level of change. If this second level of change, which that goes up 4 more than it was last time, and I can call this like the delta delta if we want. I'm really abbreviating this stuff, so especially Max, if you're still confused, or if anybody else out there is still confused, feel free to post more questions. I can make more videos about this. But we see that the change in the change is consistent, which means that this first level change is not that dramatic. It's not going to be exponential. Those exponential changes would be more dramatic. We can get rid of that parent function as an option, which now, and this might have been an option that you explore before you think about the exponential route. I just kind of wanted to cross it off our list. Now we think about what about quadratic relationships, where the input is squared and the input is always raised to the second power, as opposed to an exponentials where the power changes. And actually, we can also think about situations where maybe it's to the third or to the fourth or to the fifth power, but because there's not a huge discrepancy between my input and my output, I really think if this is anything with an x to a power, that it's going to be the squared power. So let's start exploring this parent function. And actually, I'm going to write it up here, a times x squared, and then get rid of it down here. So if we start thinking about what happens when I square the inputs, I'm going to make a little table over here where we have the x and then y squared. And because my black marker is easier to write with, I'm going to switch to that. So let's kind of section this off. So if I have an input of 0, well, 0 squared, that's nice and easy. If I have an input of 1, 1 squared, don't fall in the trap. 1 squared is still 1. If I have an input of 2, 2 squared is 4. If I actually, sorry, this is not y squared. We're making this x squared. My apologies for misspeaking that real quick. If we plug in 3 for x, we have 3 squared is 9, because 3 times 3. If I plug in 4, I have 16. Now what we're trying to get to, the y's that we have in this situation are 0, 2, 8, 18, and 32. So what we want to ask ourselves, that really comes down to where this a factors in, is what else needs to happen to get me from the x squared to the values that I want. And we can see that this list of y values that we actually want are all in a relationship with these x squared values being double. So what that tells me about the function that we can now create for that table, or that list of ordered pairs, is that this output set is double the input squared. So this becomes our function to describe that table, or that set of ordered pairs. So Max, hopefully that helps, and anybody else out there that stumbles upon this video, hopefully that helps you get a better handle for when points actually make a quadratic or a parabolic relationship. And of course, if you want some extension on this, this would have only been showing one side of the parabola. So if we want to extend this a little bit more, these points would have been over here, and there will be clone points on, my drawing's not going to look great, on this side with just the negative x values. So we could also say that there exist points that are -1, -1, +2, -2, +8, -3, +9, because we know that a negative number squared will become positive, and then when we double it, we're going to get those same output values. Sorry, not -3, 9. It would become 9, and then it would become 18 after we double it. So a little bit on parabolas there. Hopefully that helps. And Max, I'll see you in class next week.